Hi, everyone. I think let's start first. So first of all, wishing a warm welcome to everyone over here. Today will be the first of the GDI Energy Seminar series, and today's topic will be about introduction to electricity generation. So we are going to talk about things like our fuel sources, what we use to generate electricity in Malaysia, the carbon intensity of it, how much carbon we emit when using these sources, electricity tariffs, how they are calculated, and also potential challenges that we would face when we are trying to introduce renewable energy sources to our grid. So before we start, I would like to have a few reminders. So any questions that you want to ask, please try to do it in the chat, and we'll have a separate Q&A session at the end of the seminar, just so we do not disturb the flow of the seminar since there'll be so many participants. And secondly, just try to keep in mind that our audience are of a diverse background. So not everyone has like extensive knowledge of the energy scene. So our speaker today will be using a lot of analogies to explain it in layman terms to make it simple for everyone to understand. These might not be 100% correct, but we get it as well. So the whole point of it is to just get the concept across to everyone so that everyone can understand no matter their background. And the last reminder would be, please do not leave once he's done with the presentation, because we would like to take a photo of the whole group. So I would give a reminder again later just to quickly turn on your camera so that we can get a group photo. That's all for the reminders. Now, let me just give a quick introduction of our speaker today. Our speaker is Mr. Sharan. He is an energy researcher at our GDI energy cluster. He's from Parti Sosialis Malaysia, and he's part of the Central Committee and also the National Coordinator for the Bureau Alam and Crisis Iklim, Bureau Alam Sekitar on Crisis Iklim at PSM as well. Besides, he also holds a position of Setiausaha Negeri Melaka for Parti Sosialis Malaysia in Melaka. So, Sharan, would you like to take over? Without further ado.
Okay, perfect. Okay. First of all, apologize. I'm actually having a very bad voice broke. My voice actually kind of pecah because of yesterday for a particular rally. Okay, so thank you for joining us. My name is Sharan Raj. I'm with Parti Sosialis Malaysia. And I would like to introduce you to the electricity generation in Malaysia, how the electricity landscape it works in Malaysia. Okay, and I'll be using a lot of analogies. And this analogy was designed specifically for people with minimal working experience in the energy industry. And they were based on common things that a lot of people know, things like water pipes operation, car engines, and something like that. Okay. So the analogies are used to give you an understanding. It is not necessarily technically correct, but it gives you an idea how things operate. Okay. So there will be four things that I'll cover today. One will be on power plants. Two will be on the regulatory framework or the landscape, how things operate in Malaysia. The third one will be grid operations. That will be very important. And then the last one, tariff. I know a lot of you are actually very interested in tariff to know how actually it's calculated. And a few things that you should know today, some basic terms that I'll use is giga, which is about 1,000 mega. And then the other one is 1 million kilo. So this is common basic terms. And two things that we will repeatedly use will be alternating current and direct current. So direct current are the one that is used to power your fridge, which comes out from the 3-pin plug. And then direct currents are the ones like your batteries, your phones and stuff. So alternating current cannot be stored in its form, and direct current can be stored in batteries. Okay. And okay, electricity grid is just a common understanding for everybody. It's just a big electrical circuit. You open up your computer and you get a motherboard, take that and times by 1,000,000 times. So it's just another large electric circuit that brings power to your house. Okay, now moving forward, okay. First thing that we all should know when it comes to generation planning or system planning, one of the very key components that is used in Malaysia, not only Malaysia, all around the world is energy trilemma. So throughout my entire presentation, I will be focusing specifically on what are the things that Malaysian government, policymakers, engineers, researchers, and the material condition that has been taken up, that has been used to actually come to where we are today. So when you look at energy trilemma, there is three things. One will be energy security, second will be environmental, third will be energy equity. Of course, globally, all these terms interchange, but overall, they focus on economics, equity, as well as environment. So when you look at energy security, we look at the fuel source, we look at the price of the fuel, technology, and so on. So when you talk about fuel source, whether you talk about it's a domestic fuel or is a global fuel, or do you need to import your fuel? Okay, because fuel that is produced domestically, the government has higher control over price, it has higher control over the supply, and it is more stable. Now, when you are importing, you are prone to geopolitics, you are prone to embargo, and this can actually lead to serious price inflation, right? And the other one, when we talk about fuel, which is very minimally discussed, is about the technology. Whether you talk about, say, example, let's talk about nuclear reactor. Nuclear technology is not indigenous to Malaysia. You need to bring in, you need to import the technology from a particular friendly country. You need to retrain your people. And when you talk about reliability, is the ability for you to get the spare parts to when you have a breakdown on your power plants and so on. Okay. And when you talk about technology reliability and also sovereignty, is how much of the manufacturing are done locally. And energy trilemma does not only can be utilized for generation for power plants. It can also use for the power grid management, your transformers, your cables, all of that. Can you actually procure locally, or do you have to import most of it? And the technology reliability and sovereignty is very important because it dictates, one, the ability for you to operate efficiently. Two, it tells the period of breakdown. There will always be breakdowns of your power plants, your transformers, your cables, all of that. And how fast can you procure your spare part that matters? And if it's a domestic one, you can actually procure faster and you can ramp up. If it's a foreign one, you maybe have to wait. And to make matters worse, if it's a foreign manufacturer from a foreign country, you may have to bargain, or you are being put at edge to fork out a higher price. And all of these will have impact on your energy as well as your environmental sustainability. Now, when you look at environmental, you need to talk about the impact of the power plants and the impacts of the power grid on the environment. Large thermal power plants require a lot of water for cooling as well as to produce steam. The effluents that comes out from it is not only as simple as the smoke from the chimney. You're also talking about when you burn coal, you will get coal ash. So what do you do with that effluent, right? And then you talk about landscape. Now we're talking about wind power, solar power, how much it actually changed the landscape. Do people agree with it? Do you actually on the part of Bird's Migratory Park? And when you talk about now the very ongoing issues is climate crisis, the carbon emission that comes out from the power plant. And the very recent thing that now comes out is land competition. This is largely because of solar. Solar farms need huge amount of land tracts, and they do not occupy urban spaces, rather they occupy rural spaces. And you're talking about agriculture lands. So now there is an issue for land competition, and it falls under the environmental trilemma. And the last part is, what do you do with once it's over? Every power plant has a lifespan. How do you decommission it? Is it easy to decommission it? Or do you have like a nuclear fuel which you have to live with it 40,000 years? And all of this comes into a comparison. And the final part will be energy equity. We talk about the price accessibility. Is it cheap? Is it affordable? Is it stable? That's what most of the consumers and people want. And you must also talk, when you talk about energy equity and financial remuneration, you have to talk about workers. You need to have a sufficient amount of wages to attract talent. You need sufficient amount of wages to pay the suppliers. You need to pay the consultants. You need to pay academicians to fund research and all of it. And all of these companies must be funded within this energy industry. And in the tariff should reflect that. And it should also reflect energy poverty. When we talk about energy poverty, it's not only about the price cost. Example, if you look at the minimum Malaysian life standard, is now most of middle income people has an air conditioner. But there are nearly 50% of our country population who do not have access to air conditioner. So that you can consider as energy poverty. There are single mothers in this country who do not have fridge because they can't afford fridge at the first place. Neither they could actually afford to pay the electricity for the fridge. So this is considered energy poverty, where they do not have access to a minimum amount of energy to meet the median the median lifestyle of the country for that. And the other one will be the use of social advancement. Electricity is a social advancement tool. When you have lights at night, children can study. When you have access to electrical rice cookers, kettles, and stuff, the amounts of burden on household chores reduce. And the very reason which Malaysia actually had it in the 60s and 70s is electrification rate. Today, we have achieved near universal electrification rate at about 90%. Of course, you break down to Semenanjung is 99%. There's still less than 1% that has not been electrified. And that is because the last 1% are majority orang asli, and they are living in quite rural areas, deep in the forest, and it will be very hard for us to get to them without chopping down the trees and making ways for roads and construction materials. That's one. The other thing is a lot of the orang asli in our countries are also to a certain extent quite nomadic. They change place, and electric infrastructure is a static infrastructure. You build in place where people permanently reside. Now, when they constantly in shift, it makes it very hard for you to connect to them. And efforts are being made in Malaysia, particularly in Sabah, as well as in Semenanjung, to have common areas where the orang asli could come and charge their phones and so on. Of course, in day-to-day basis, week and seasonal basis, they still rotate around, but you have some sort of common areas, and there's a time to close that gap. In Sarawak, where electrification rate will expected to hit 100% by 2025, the Sarawak state government has been reinvesting their electricity profit in rural electrification, and we expect to reach 100% by 2025. And it's safe to say by 2025, Malaysia will actually reach 100% electrification rate, at least by the bare minimum. So this will be something very important. And in Malaysia, this is a analysis that I've done. A domestic household resident should not pay electricity bill makes up more than 4% of the minimum wage. So our minimum wage is at about 1,110. So they should not be paying more than about 40 ringgit for electricity per month. So, and that is where you call it the energy pricing is actually accessible. You benchmark it to the minimum wage and make sure it's not more than 4% of the country's minimum wage, right? Now, moving forward, let's talk about power plants, right? So there is a power plants needs energy source. There is no such thing as free energy. If somebody say there's something called free energy, no. Energy can only be converted. You need an energy source, and you convert that energy into electricity. Electricity is not an energy source. It's a form of energy, and you need to convert it from some type of fuel. Every electricity needs some type of fuel. So now when people say, oh, solar, it's free. No, not really. You need sun as the fuel. If there's no sun, there's no electricity. So the two major energy source for Earth is, one is the sun, second is the geology energy, okay? Right? And why I say so? Okay, now the sun energy is used, and then of course you have photosynthesis, which is a form of biological energy, eaten up by the dinosaurs, by humans, by everybody else, and then of course things rot. But without the geology energy, which is pressure, okay, it does not become fossil fuel, okay? And the more amount of geology energy, which is the pressure, there's a lot of pressure on the Earth which puts onto all this decaying fossil. The more pressure it puts, the more carbon, how do I say, it becomes more easier to burn, okay? Because like coal is the youngest form of fossil fuel, and the more geology and pressure and heat that you put onto it, it becomes liquid, which is black oil that becomes aviation fuel, diesel, petrol, that you know. And you put more geology pressure on it, more geology energy on it, and you get your gas, right? So geology mixed with sun is actually fossil fuel. Some people say fossil fuel is directly a form of sun. No, it is actually a mixture of these two fuel, okay? Now, humans have also learned to make fuel directly from organic materials, which now we call as biomass. So in terms of biomethane, biodiesel, we also have biocoal, where waste from rice husk, waste from palm oil, and so on, can be converted to become biomass, right? And sun energy can also be harnessed in form of wind. Waves can also be form of solar, right? And humans also have learned to harness the geology energy in form of geothermal, where we pipe fluid into deep earth and use the heat to actually derive that. Okay, so this is actually very important. Why do I am emphasizing it? Because we need some form of fuel, and that fuel is necessary. It can be your sun, your solar energy, your photons, your biomass, anything, and that is the prime component to generate electricity, because electricity does not exist on its own. It needs to be converted from somewhere. And if someone asks me, okay, fine, you said energy can only be converted. So where did the geology and sun get this energy from? It's from nuclear. To be specific, it's actually atomic energy. And that atomic energy, when it's fused together in sun, is what you get the fusion reactor. So sun is actually a nuclear fusion reactor, right? And that is what we are harnessing. And atomic energy, when you put them together, you clump up together, you get gravity. So that's where the pressure and the geology pressure you get actually on Earth. And of course, we humans have learned to use atomic energy in the form of nuclear, right? So these are all the energy sources available from us to actually now make our electricity. Now, let's talk about power plants. So power plants, you can classify them not based on their fuel source, but on their operational source. Okay, what do I mean by operational source? So biomass and fossil fuel, both from organic, they are quite same. And they can be converted into electricity in three mechanisms. You can either burn it in a combustion chamber. This is usually for solid fuel, like coal or biocoal or charcoal. Okay, or you can burn the liquid fuel such as biodiesel or fossil diesel into a diesel engine. Okay, and yes, you can also talk about petrol engine to generate electricity, but nobody, in Malaysia we don't do that actually, except the Pasar Malam guys, they actually use that. And then we use a turbine for anything that is gas in nature. So some of you may be looking at the gas turbine, and the gas turbine, which is on the far left, it looks very familiar. Yes, it is modeled after the aeroplane turbine. It is the most efficient way for you to burn a gas, okay? And the heat from the back of the exhaust is actually used to generate electricity. So collectively, okay, and this one all forms what we know as a thermal power plant. A nuclear power plant is also a thermal power plant because you use a nuclear fusion or fission reactor. There's two types of nuclear reactor. Yeah? One is a fusion. Okay, one is a fission. So one of it, you actually split the atoms, which is the uranium, thorium, and you break it into smaller. And the other one is where you fuse two atoms together and you produce huge amount of heat energy. Okay, fusing two atoms together, which is known as fission reactor, which happens in the sun, is very uncommon on Earth. We are still learning how to harness it. It's a clean technology, but we are still at least 50 to 100 years away before it can actually be fully adopted by human civilization. And so from all of this, we actually, what happened to my slide? Okay. Right, okay. So all of these produce heat, and this is known as thermal power plants because the heat from this thermal power plant is used to generate kinetic energy where we move a turbine. And when we talk about geothermal, it is also a form of thermal energy because you convert from any type of fuel into heat first, and from that heat, you actually generate kinetic energy, and that kinetic energy is then converted into electricity. Okay, so when you look at nuclear, when you look at geothermal, you look at the gas turbine, and you look at the solid combustion chamber, they actually burn something or they derive their energy source from some sort of fuel, and that heat is actually converted into steam, and that steam is then used to actually move the power generator, and that's where you got your electricity. Okay, now we also have non-thermal energy. Okay, non-thermal energy, you have hydropower. There's two kinds of hydropower. One is known as runoff river, and the other one is storage hydropower, which most of us commonly know. So the difference between both, runoff river hydropower, it does not create pond. It does not create huge amount of what we call as a storage area. So it captures the natural flow of the river, and it's more environmentally friendly than storage. And then we have wind. So all these three are directly is a kinetic energy, and they capture it, and which is also later converted to electricity. Now, there is very one thing interesting about solar. Solar remains a very revolutionary technology for human because for the first time, we have directly converted sun energy, which is from photons. Yeah, it's a type of atomic, and we convert it into electricity by skipping all this organic conversion, fossil fuel, geology, pressure, everything, and we directly convert. So it's actually a revolutionary technology for human, and it is a classification of its own when it comes to power plant, right? Now, there are three types of power plant, okay? And this power plant, it depends what is their role in the grid and where they're placed in the grid. So when we talk about utility generation power plant, they are the large power plant that we commonly know. They are far away from city areas and they generate electricity to plug into the grid, which later you receive it at your home, okay? And then there is another power plant which is known as self-consumption. Also, these are mostly in Malaysia used by palm oil mills because they are very far away from the grid or the nearest entry point to the electricity. And they run mostly on diesel generators. They produce electricity for themselves and they do not have any connection or export or import with the grid for that matter. So this is called as self-consumption, sometimes known as selco. Okay. And now the other one will be self-generation. So this power plant, they are built very close to the consumption point and is usually behind the electrical meter. And previously, before the existence of solar panel, only industries, large industries, had the options of self-generation, and they are called as co-generators. So they buy their fuel. In Malaysia, most co-generators are powered by gas, and then they use it to power the factory. Okay, and now thanks to solar panel, even residential house, they could actually generate themselves. So now everybody is becoming what known as a prosumer. They are the producer, they are the consumer. So these three are the types of power plants existed in Malaysia. Okay. Now, what is so great about co-generation? I had to highlight about it. Okay. Co-generation, first of all, now let's look if you don't have a co-generator. The industries that require co-generator are the industry that needs a lot of heat energy, and mostly these are chemical, petrochemical, glove manufacturing. To a certain extent, hospital use them and stuff. So they require heat energy. So common industries who does not have a co-generator, they actually take it straight from the grid and then they convert it into heat in their own plant. Okay. And when you look at a typical power plant, since Malaysia's co-generation are mostly gas, I'm going to compare with it. Combined cycle gas turbine. So this is the most efficient fossil fuel power plant you can find in the country. Okay, so only 60% of the entire fuel energy is actually converted to electricity. 40% is heat and they are dumped into the sea. Okay, most of Malaysia power plants are at the coastal area and the heat is dumped straight into the seawater. And when you look after it goes to transmission, okay, you have a loss of 9%. And when you convert that electricity into heat in your factory, you lose another 1%. So cumulatively, your efficiency is just 50%. So only 50% of the fuel was actually used as useful energy. The other 50% is lost in other forms. Now, when we look at co-generator, what's so great about these guys? Okay, so a co-generator power plant with a gas power plant, they actually buy the fuel straight. In Malaysia, it's sold by Gas Petronas or or Gas Malaysia, which belongs to Malakoff. So these are the two biggest suppliers of gas to factories. And these factories, they have a small mini power plant. So from that power plant, they use the electricity to power their lights, a few machines, this and that. And the heat waste that comes out from the co-generation plant, okay, and this plant is known as combined heat and power, by the way. And it is used for their manufacturing process, right? And it still has a loss of 25%, which cannot, at certain case, cannot be recovered because though it is still hot, it is still hot enough to burn you, but it is not hot enough for you to undertake that specific industrial mechanism. So there is a loss of 25%. And there have been more advanced co-generation plant, which is known as tri-generation, where it makes use of the 25%. So you push your efficiency up to 90%. So you derive more useful energy from per unit fuel. And since this factory does not pull power from the power grid anymore, it puts less pressure on the power grid to actually meet that demand. Okay, and the overall efficiency you can expect to be at the range of 75%. Okay. Now, one of the common things everybody asks, what's the difference between installed capacity and energy generated. This is largely a very, very confusing term to a lot of people, because common people think installed capacity means that is energy generated. So now I'm going to make two comparisons. I'm going to use the analogy of motorcycle and bicycle. So now we have Saudara Simon, which is a cyclist, sorry, not a cycle. So he assumed he's now a solar power plant. And then we have Kennedy, and he is now the coal power plant, and he has a superbike. Okay, so right now when you look at them, so the fuel for Simon here, because he's pedaling, so it's fuel lump. Okay, and the fuel for the Kennedy's motorbike is largely petrol. And so when you look at the maximum power, the strength of Simon could pedal, the best he could do is about half a horsepower. So some people remember car as horsepower, yeah. And that means that is the maximum amount that work that he could do at that moment. Okay, and of course, when you look at a motorbike, you just put a petrol, it actually can speed up very fast. Okay, but what we need to measure when it comes to the climate crisis is the energy generated, which is in this case will be distance. Oops. Okay, in this case will be distance. Okay, why for that matters is, okay, because we cannot look at the, say, okay, you have a cycle looks good, but it needs, the work done is actually distance. That is the energy generated, not the capacity of Simon, not the capacity of the motorbike. It is the work done is energy generated. Installed capacity is the strength of the motorbike or the strength of the pedaler for that person, for that matters. Okay, and why? Okay, now why that matters in the talks of climate crisis is because it determines your carbon emission. Okay, so now for an example, this was a recent statement by the Minister YB Samsul Anwar saying about Malaysia wanted to reach 31% install capacity by 2025. So everybody thinks 31% means, which means 31% of our electricity is going to come from renewable. Okay, no, not really. Not really at all. It's not anywhere close actually. Okay, why I say so? Because we need to look at what install capacity means. Okay, when we talk about install capacity, like I said, it is the maximum power. So a coal power plant can run 24 hours, 365 days a year, non-stop. Okay, but a solar, and it needs sun as fuel. Yeah, I said that's where fuel is important. And in Malaysia, you're talking about 6 to 8 hours, okay, maximum. And the peak output for solar happens at noon. Okay, so it doesn't mean you have 1,000 megawatt of solar, it produces 1,000 megawatt hour at 9 o'clock. No, it does not necessarily mean that way. So when you look at a comparison between coal and solar, the amount of distance covered by coal is actually 6 times more than solar. Okay, so Simon, he looks very environmentally friendly. He's going around in a cycle, but it cannot produce the same amount of work or distance covered by Kennedy within that short 1 hour. Neither he can actually compete in terms of carbon emission. Okay, and does it really matter? Yes, it makes a very, very big difference. This is the 2018 comparison of installed capacity and energy generated in Malaysia. Okay, and when you look at the difference, just look at the coal. Let's just look at the coal. So in 2018, coal power plants installed capacity, it's only about 31%, but it produced 43% of all electricity needs in this country. So to put it in an analogy, so I have one Yamaha motorbike, which Kennedy had, but I have 10 cycle. Okay, so as an environmentalist, I say I have 10 cycle, I have one motorbike, so I look green on paper. Okay, but I do not use my bicycle at all. And even just to go to the shop in my front house, I'm actually using motorbike. Okay, and because of that, I am consistently pumping out CO2. Okay, so I have bicycle, but I'm not using it. And that same goes for you. So the question is, how much of your renewable energy, how much of your carbon-free energy or carbon minimal power plant is actually running? So that is energy generated, the distance cover. So that is where you need to look, not install capacity. You can have 30,000 megawatt, you can have 90% coal, no problem. But if you're not using it, that's not an issue. The question is, how much of it is using it to produce electricity? Okay, so it makes a very, very big difference, because you look at the difference from here, coal actually only makes 30% of the available power plant. So it means it's 30% of the cars, but it actually travels up to 43% in distance for that matters. Okay. So now, when YB Samsul Anwar said we are measuring by install capacity, did he lie? No, he did not lie, because he used install capacity. So he was technically correct. So what do you call this? You call this greenwashing. It was misleading. For common people, 99% of the population can't tell the difference. They will assume when he said 31%, 30%, 40% of install capacity, they will assume 40% of the electricity is coming from renewable. In reality, it's not. So you will be thinking that, okay, which means we have to calculate by energy generated, correct. But previously, then the previous minister, Yobi, she had actually calculated the electricity in the form of generated in 2019. So we actually adopted a very better standards. Of course, later when Perikatan government came into the picture, to make themselves look good better on media and stuff, they actually start using the word install capacity instead of generated electricity. So we actually went backwards in that sense. Yeah. Now, power plants, they have three purposes when you come to a utility generations. Okay, they have three major roles. Now, what you're looking at is actually the Semenanjung Malaysia's demand. That is the electricity used on the 1st of August, but 2 years ago. I did not use the post-COVID. I'm using the pre-COVID. So this is how there. So when you look at the peak over there, that is the peak, the maximum demand. So that is the maximum amount of what you call your horsepower that you need to keep the system running. And there is something known as base load, which is powered by base power plant. And please bear in mind, it actually starts at 10,000, not zero. Okay, so our base load in Semenanjung is about 12,000 megawatt. That is a lot, by the way, because we have a lot of industries in Malaysia running 24 hours, 7 days a week, non-stop. Cement, electronics, certain manufacturing power plants, smelting, iron. These factories run 365 days non-stop, 24 hours. So because they are running non-stop, they are demanding. So they are known as base load. And at about morning 6 o'clock, it starts going up. And this is where it's known as a peaking day load. And they are met by peaking power plant. Okay. So the base load power plants are power plants that operate 24 hours non-stop. And the peaking power plant actually starts working slightly after 6. And like I said, AC electricity cannot be stored. So you start your power plants when the demand or when the load goes up and it ramps up. And in Malaysia, most of our load actually starts quite early compared to a lot of countries. It starts at about 6 o'clock. It's because we are a Muslim majority country. Most of our Muslim friends, they wake up at about 6 for their Solat Subuh. They start showering. So this is that small tweak is the increase in residential demand. Okay, right? And as your days goes on, you have your schools, your operations, all of that goes around. Your shopping mall starts operating. And all of that pushes your maximum demand before it starts going around until nights and everybody starts going to sleep and it goes down. And then the whole cycle repeats. So we have three types of power plant, and three purposes of power plant. One is base load, one is peaking power plant, the other one standby power plant. So how do we choose which power plant becomes which? Okay, now the base load power plant will always be known as the slowest ramp time. Okay, what is the slowest ramp time? That is equivalent to the time you take to start your car. Okay, you go into your car, you start, you have to put in a manual gear, and then you press your clutch and everything, and then you start moving up. So it takes at least a few seconds, so maybe 10 to 12 seconds for you to actually from start. That if your car is also a manual starter, it'll take the time to start. So all of that is timing. And base load power plant, like coal power plants, majority of Peninsula's base power plant, which runs 24 hours non-stop, is actually coal, and they have the slowest ramp time. It can actually take sometimes up to a half a day to actually start from shutdown all the way to that. So once we start it, we don't actually shut it down, okay, unless it actually stops for breakdown. And it has the largest generation block. Okay, you may ask, what is a generation block? Okay, when we plan a power plant, we look at the power plant rating, it says about 2,000. But when you look closer, the power plant internally are broken into 4 divisions. Each one of them is one. So we call it as a generation block. So in this case, a 2,000 megawatt power plant has 4 different subsections. Okay, and they're not connected, but the total output from the power plant will be at about 2000 megawatt. So why do you do actually a generation block? Say one of the block actually goes down, the other 3 generation block runs. So out of 2000, at least 1500 runs. So this avoids you from losing the entire power station just because if you have a repair for one particular. So you break into a few different generation blocks, okay? And generation blocks are usually for baseload power plant, they are huger, peaking plants are smaller, okay? So now when you look at the peaking power plant, of course, it has to be the fastest ramp time. It needs to be come up online within 30 minutes. Most of our peaking power plants are known as combined cycle gas turbines, CCGT. And they come online within 30 minutes to 2 hours at sometimes. Depends on the power plant's response time and also that. And which power plant becomes peaking power plant is you look at the cost of it, how much the cost per electricity coming out there. And this is done by efficiency. Why we look at efficiency? Because it depends on the amount of fuel that goes in and how much electricity do you get from that per unit fuel. And they usually have smaller generating blocks compared to the base load power plant. Now, the standby power plant, they have few things in common. They will be the oldest power plant in the region, and they have the lowest efficiency because they consume more fuel for reach the same per unit electricity. So we use most efficient, and they are kept there. And for that sense, they make it more expensive. And a lot of standby power plants are now actually they close to populations. Okay, so if you look the power plants in Putrajaya near Sedang, which is behind IOI Mall around there, and you look at Penang on the island and stuff, this power plant rarely operates because they are very close to populations. So we do not operate power plants close to population center because every time power plants operate, it churns out huge amount of CO2. Okay, so that is how you decide which power plant runs and so on. And just on the caveat thing, the baseload power plant, mostly coal, which was decided in 2009 by then Najib administration, is not valid anymore because officially coal is now one of the most expensive cost of generating electricity. And in 2018, just before COVID, the coal price actually went up so high, actually became a serious headache for the ministers and Tenaga at the time. Okay, now let's move on to the landscape of energy, how it works. Okay, so in Malaysia, we have 3 regions of electricity, Semenanjung, Sabah and Sarawak. Semenanjung and Sabah are jointly managed by the federal government. It's under the jurisdiction of Suruhanjaya Tenaga, and the development of renewable energy is under SEDA, which is under the Executive Ministry of KETSA, and all laws for these 2 regions, which is Semenanjung and Sabah, comes out from the parliament. Sarawak has full autonomy and jurisdiction over its electricity, and they have a Ministry of Utilities of Sarawak. And the agency is known as Electric Supply Division under MOUS, okay? And the powers is quite actually extensive compared to a lot of OECD countries or even America or anything, because master policy, power plants license, standard, tariff, all of this is actually done by the government, okay? Whether it's the state government or the federal government, is actually done. So the role that is played by the operators, they are just operational, that's it, okay? And when you look at the landscape of operations in Semenanjung and Sabah, we actually have IPPs, which is the private capitalists. And then when you look at what belongs to the to the government-linked companies, all Tenaga Power Generations, it comes under Tenaga Power Generations, also known as GENCO. It's a short form for Generation Corporation. And when you look at transmission, it actually has been split. Okay, in Peninsula, we have something a bit more fishy. Not really fishy, 2 small fish, okay? Malakoff Utilities actually is the distribution network for KL Central. So if you have a house in KL, one of the condo in KL Central, you don't pay to Tenaga, you pay to Malakoff. And if you are in Kulim High Tech Park, you pay to Nur Power Sdn Bhd. So they are the distributors. So the meters belongs to them. Okay. In Sarawak, it is 100% vertically integrated. It's only owned by the government themselves. Okay. And private IPPs are only exclusive to Semenanjung and Sabah. They are non-existent in Sarawak at all. Okay, and TNB Genco is actually being restructured as a form of IPP model. So what damage does it done? So we'll talk about tariff later. And during Mahathir's time, he was a big proponent of penswastaan. Of course, now it's called liberalization because now penswastaan is actually a very, very bad word in the industry. In the energy industry, it's called a bad word. It never make anything that is good. So there has been stopped. Why? we will discuss that later in the grid there. Okay, so these two guys, the Malakoff and Noor, is the last standing distribution. They have exclusive license privileges to actually collect electric bill in KL Central and Kulim. Okay. Now, when we look who owns Tenaga Nasional, okay, everybody wants to know where the profit goes. Okay, so majority of the profit, actually 70% goes to GLC. Government Linked Investment Corporation, GLIC for that matters. Okay, and so this is one of the arguments people say TNB profit goes back to the people. Not really. If you look at KWSP, only a handful of people control the majority of the capital in KWSP. So the profits from Tenaga is actually also consolidated in few hands. So, but this is also in a way what we call the operations of state capitalism. They say that the profit actually goes to the people, but it's consolidated by a few bureaucrats, a few people with large capitals, few technocrats, and for that matter, so it's not vastly actually enjoyed by the people. So I need to make that caveat because one of the very common rumors they say is TNB profit is enjoyed by the people. I really dispute that. Okay, and when we talk about Sabah, Tenaga actually owns SCSB, the Sabah Energy Sdn Berhad. It owns majority share, and it's in 17% belongs to the Sabah state government. And as I mentioned just now, Sarawak owns 100% of Sarawak Energy. It's vertically integrated, and all profits from Sarawak Energy is actually recapitalized to developing Sarawak, and is also used to fund a lot of development in Sarawak actually. So that is something we can actually verify from the Sarawak Energy annual report. Okay. Now, when we look at the landscape of IPP capitalists in Malaysia, of course, there is a combination of private capitalists and state capitalists. In Malaysia, we actually have two federal capitalists, two national capitalists for that matters. Of course, Tenaga Nasional belongs to the government of Malaysia. And the other one will be EDRA Energy, which is owned by CGN. Okay, China's General Nuclear. Okay, EDRA Energy can be some familiar for a lot of you. Is actually was part of the 1MDB scandal, where power plants belong to Tan Sri Anandakrishna and a few private crony capitalists. Was bought over by 1MDB Power, and later when it had into a huge financial rundown, it was sold to the CGN, which is the China General Nuclear, right? And which is now known as CGN EDRA. Okay, and they are the only foreign entity that has the majority shareholder in our power plants. Before 1MDB, all our power plants were locally owned by local private capitalists. And of course, later because of 1MDB scandal, it has changed. And now the central government of People's Republic of China, also known as Beijing, is also actually one of the key capitalists in our country. And the other two small version guys will be the Selangor State government as well as Negeri Sembilan. They actually have some stakes in Pulau Indah power plant, which is controlled by PKNS, and this was approved very recently. Jima Energy Venture, it's a coal power plant, which is the Menteri Besar Incorporated for Negeri Sembilan, actually owns some share and is also jointly managed with Tenaga Nasionals. Okay, and these two states are also controlled by Pakatan Harapan, which is also formerly they used to condemn IPP, but state also actually has a lot of interest in IPP. Okay, now who are the private capitalists? Okay, so private capitalists at the moment existing one. There's a lot of former, but I didn't go into the former one. Of course, some of the very famous former capitalists will be Tan Sri Anandakrishna. So the current one will be Tan Sri Syed Al Bukhari, which is Malakoff, YTL through YTL Power, and this is Tan Sri Hamdan from Ranhill Berhad. So Ranhill's power plant is actually based in Sabah. It's none of it is actually in Peninsula. Those in Johor may know Ranhill because they're involved in the water operations for the state of Johor. And we also have a royal capitalist, which is the Palace of Johor. The Sultan Johor directly owns about 30% in Southern Power Generation, a power plant in Johor. He previously held a majority share, but later the share was actually deposed to Tenaga Nasional Berhad. So Tenaga Nasional Berhad now is the biggest there. And when you look entire IPP in Semenanjung, it goes around within the same people. It's always the Malakoff, it's TNB Genco, it will be EDRA Energy. So it's always play around with the similar people. And it's more or less safe to say it's an oligopoly. It's become an oligopoly rather than a open competition. Now, let's talk about the electricity grid. Okay. Now, briefly, when we talk about the electricity grid, this will be a common operations. But where does the grid starts and end? Okay, so the grid actually ends at your housing meter. The meter in front of your house actually belongs to the utility company. It's their property. So beyond that point, that's where your house wiring is not them. Okay, and then beyond the point what is known as coupling point or the transformer entry point for power set, that whole thing is known as electricity grid. Okay, and electricity grid operation is very, 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 very important. Okay, now since we always like to talk about meter, I want to cover some things because everybody hates the meter in front of their house. There's three types of meter. Of course, analog meter is nearly non-operational in Semenanjung, but it's still in operations in Sabah and Sarawak. Okay, it is the least accurate. It decays very fast. So which is why when the switch between analog to digital meter happens, a lot of people suffered a huge spike in their electricity bill because all this while analog meter decays very fast because of wear and tear. And due to that, you have always been underpaying to a certain extent. Okay, but is there a probability of a measurement defect? Yes, there can be a measurement defect. Meter units quality is regulated by Suruhanjaya Tenaga for Semenanjung and Sabah. And when you look at the meter unit for Sarawak, it is actually regulated by the MOUS, Ministry of Utility of Sarawak. Okay, so they don't actually tamper with it. And you can always say, oh, DNB can tamper to make more money. Okay, they won't. Why? You will know in tariff later. Okay, and this is the latest generation known as smart meter, which is being now installed. They were installed in Malacca several years ago, and about 5 years ago. Now they have started installing in Klang Valley, and it's expected to cover the entire peninsula by 2026. So what is so great about a smart meter? Well, basically it comes with internet connection, like your mobile phone. So it relays all your electricity energy usage in 30 minutes interval, not real time, 30 minutes interval to Tenaga. And Tenaga can upload your electricity usage to your phone apps or to your internet. So you can see your hourly usage of electricity, okay, and then they can send your electricity bill by email. So the guys that goes on motorcycles comes to your house on month-to-month basis to actually record your electricity bill. The job may not exist by end of this decade. Hopefully they get another job beside Tenaga and they're not retrenched. Okay, and now the grid electricity, one of a very major component everybody needs to know is stability. Okay, our grid operates at a frequency. So what is a frequency? You can look at frequency as a form of pressure. Okay, and this pressure needs to be properly regulated at a very high precise. Okay, and it is regulated in a very small range. Okay, you can only deviate by 0.5 hertz. Okay, hertz is a measurement of electricity or energy between the power plant to your house per second. Okay, so you may find it confusing. Long story short, electricity, one electron travels between the power plant to your house 50 times within 1 second. So within a snap of my finger, it is actually to have traveled 50 times between the power plant and to your house. So that is what we call it. So, and this frequency needs to be maintained. Why? You need to look at it like a water pressure. So if the water pressure is too high, how does the water pressure become high? So when you actually have the water pressures into the pipes, when you put so much of volume and the pressure increases so much, what happens? The pipe bursts. Okay, because you're putting in so much of water, but people are not opening up their tap at their house, so it causes a lot of pressure and it breaks the pipe. Or you do not pump enough water into the pipe that when you open up your pipe, the water actually drips. Okay, so this is the analogy for frequency. So when your supply is lesser than demand, the frequency drops. And what happens? You will experience light flickering. Okay, and in industry, what happens if you have robotic arms, motors, hydraulics, you can have jerk. You can actually move and start jerking because of the under frequency. And it can actually kill people because the machine does not move in its path. And if there's a worker standing right to the machine or the automation, it can actually knock someone out. And there has been incidents, people have been killed, not in Malaysia, in some other countries because of under frequency. Hospitals, ventilators, a lot of equipment that runs on AC power requires a proper stable frequency. So frequency dictates life or death, okay? And the danger part is when you have over frequency. When it becomes more than that, you can actually have what we know as a blowout. You can have equipment damage at your transformers, your cables, your wirings. In theory, even your house air conditioner can actually blow up if it's connected in usage at that point of time. But nobody have actually took the risk of experimenting it because you do that, you have a national blackout or regional blackout for a very long period of time, and you cannot. It will take months to actually fix that level of damage, and you will have huge amount of impact on the healthcare. You will have huge amount of economics and so on. So power grid stability is very, very important. Okay. And why I'm emphasizing is because now you have a lot of solar energy coming in, and solar energy, you cannot control it like power plant, okay? Because the sun intensity actually keeps on changing per second, millisecond for that matters. And every time the supply goes in and out from solar and it's oscillating too much, and it can actually disturb the frequency. Our grid at this current stage, analog can only expect only about 24% of the entire maximum demand. I mentioned you what is the maximum demand just now at the initial log profile. So only 25% of that can actually be met by solar. Anything more, you will actually lose your coal power plant at the first. The first thing that will happen, you lose your coal power plant, your base load will go off because the frequency going into the grid, it becomes so unstable, it will actually start damaging the power plant, and then incurring you have all the blackouts coming in. Okay, so if anybody said let's add on everything we want, no, you can't do that. Okay, in America, this is very common because they have liberalized and privatized everything. Anybody can add anything to the grid. So the grid in America is very unstable. It's actually one of the worst performing grid among the OECD. There's a lot of case study done how not to run operations. People use America as an example. So this is where we have to plan it properly. Okay, and countries with proper central planning on electricity actually has better grid. Malaysian grid is actually one of the best in the world. One of the very best managed. It's slightly better than Denmark, on par with Britain. It's actually way better than China, and way better than a lot of countries, even better than Australia, better than United States, and so on. Okay, the peninsular grid is actually very, very well maintained. Okay, most of you will not remember when the last you actually had a blackout. Okay, so I need to share that. I need to give that effort because there's a lot of efforts people, engineers spent in to done this. Okay, now when we talk about grid stability, how they actually maintain the frequency is very simple. They actually dump electricity. Okay, so we produce our electricity, we overproduce it, and then we dumped it a few more. Okay, less than about only 85% of the electricity produced actually reach the consumer. About 15% is actually lost. Okay, the grid loss, known as distribution and transmission, they're lost as heat. The cables actually heats up, and there's a lot of current going through. And then when you look at frequency balance, it makes up about 7%. So we overproduce slightly. And when we saw the frequency is actually going off the safe range, and then we start dumping. We actually literally dump electricity to the ground. It's called grounding effect. And that is how we balance the electricity grid. Yes, you can say we are wasting it, but that's how we do it. But this is a very, what we call a old analog method. There are newer methods now. And the newer methods is like using batteries. So you connect the batteries, and the batteries can actually absorb and dispatch at milliseconds. So the frequency balance can be reduced, but Malaysia have not adopted it. And Peninsular Malaysia is only slated to absorb in 2030. Why? I don't know, you must ask the minister. Okay, but they actually really delay it. Although the call for the industry was to introduce by 2023, but Peninsular Malaysia will get it only 2030. Sarawak has not mentioned when they will get it. Okay, now, in Semenanjung, this is our usual transmission network, and most of them are used to strengthen for Selangor. Selangor makes 43% of our electricity demand. Okay, so it is very important. It's the central hub, but it does not have enough power station, and we're not building power stations in Selangor anymore, except the upcoming Pulau Indah. But Pulau Indah was unnecessary, but because Pulau Indah was linked to the Selangor government, which was the coalition partner for then Minister Yobin. So she approved the Pulau Indah power plant on the pretext of meeting the demand. But nobody builds power plant in urban population anymore. We are moving far, far away. All the power plants in Penang, in southern Johor, Kappa, Klang, Connaught Bridge are all going to be decommissioned by end of this decade. Or at the moment, most of them are already on standby. We don't actually run them full time anymore. Because you burn that amount of fossil fuel close to population center, you will have huge amount of PM 2.5 and pollution in the air, causing a lot of respiratory damage. So consciously, all these power plants actually shut off. But then the Minister Yobin actually she said, oh no, we need to build the power plant because it's necessary and so on. No, we don't actually need. It's actually more than sufficient. We just need to strengthen the transmission to bring power from Perak and from the south, particularly from Melaka. Melaka has a huge amount of power supply. Melaka actually has the most power plants in the south after. Okay, so now, okay. So now we talk about in Sabah and Sarawak. So in Sabah and Sarawak, they are not connected at the moment. There's a lot of microgrid. When you look at the three the circles that I've mentioned there, they're actually defragmented there. They're not connected. And in Sabah, we are doing huge amount of upgrades to the power system because there's a lot of congestions. They're not properly there. Some of them are very aging. So there's a huge amount of operations going there to upgrade the electric grid in Sabah and Sarawak. Both of them are not connected at the moment. They are fragmented, okay? And there are being attempts now to electrify them. They're known as the Borneo grid and it will be slated to completion in 2022, but of course subjected to delay due to COVID. Okay, so from there onwards, the entire Sabah and Sarawak comes together as a singular grid. So now we have two national grids. And why do you unify it? One, because it's stability, like I mentioned, the frequency stability. Second, it becomes very cheap. Because now when you go look at that, the two circles at the top is Lawas and Limbang. They run exclusively on diesel generators. And diesel generators are very expensive form of electricity compared to anything else that Sarawak has. So once you connect the grid, you can actually dismantle the diesel and it becomes more cheaper to operate. It becomes more environmental friendly. It becomes more reliable. And you will need less standby power plants. You need less standby power plants and you can put more solar. I did mention just now that solar, because it has a lot of frequency disturbance, there is a certain limit. But when you merge, you have a bigger grid, then you can actually put in more solar. So this is one of the reasons why the Europeans are merging all the grids across the continent, so they can actually put in more wind and solar. Okay. And of course, fundamentally, it's cheaper. Now, let's look at tariff. This is actually part 3. Okay. In Tenaga, in Semenanjung, we actually use a method known as unbundling, okay? And that is called as IBR ICPT, okay? A lot of acronyms, but there are two components to it. One is known as incentive-based regulation. So where electricity is actually, the price goes up every 3 years. Their regulator comes up every 3 years. The price was supposed to change as this year, January, which has been postponed to January 1st, 2022 due to COVID pandemic. Okay, and what happens in IBR is the amount of money TNB can make is regulated. Anything more, they have to be refunded. So they cannot actually overmake, they cannot overcharge. Whatever they do, this is the amount that you are kept. Okay, and of course, you may say that that amount is also high. Everything's open to debatable, no problem. Okay, and the fuel for the power plants is actually purchased by Tenaga and Tenaga subsidiary known as TNB Fuel Service. TNB Fuel Service and they purchase the pearl and purchase the fuel and they give it to the power plants, even to the independent power producers. None of the independent power producers purchase their own fuel except renewable energy, because like solar and stuff, you don't need to purchase. But things like coal, gas, diesel, they actually purchased by TNB Fuel Service and given to the debt. Okay. Some of you may find it very similar to taxi for there, but I'll go into details later why. Okay. And the other component will be the imbalance cost pass transfer. So in event the price of the fuel or coal or gas goes up, which has been going up, the cost will be transferred onto the users. Okay, and if there is an excess revenue, TNB made more than sufficient amount, or there is a huge drop in price of fuel, so that has to go in as rebate and there has to be refund. Any surplus, every single surplus of cent above the regulated, what we call it as revenue limited or revenue cap. In industry, we call it the revenue cap. It belongs to the government. Whichever they have refunded, but you say they have excess time, they don't know how to give it back. You give it to and government goes to 1 into 3 electric. Okay, so this is the average tariff in Malaysia when you look at that small little box there. So that is the breakdown of costs, and a cost of 1 unit of electricity in Semenanjung costs you about 40 cents. Okay. Hello. Okay. Now, when you go further now into IBR, there is actually 2 components to it, and all of it has been broken into split. Okay, so when you look at TNB's single generation, its grid transmission, everything as revenue capped. Okay, so they cannot actually make extra profit. Their profit has been capped. There's no way they can make extra profit from their grid operations. Okay, I'll repeat, it's from their grid operation. It is heavily regulated. Why I'm saying from grid operation? Because TNB Genco is profit does not come under this revenue cap. Yeah. Okay. And when you look at that, okay, the IPPs, there's 2, the TNB Genco and the private IPPs. Previously, all TNB power plants was actually on type what as a bundle cost. So the electricity that is generated is given to TNB transmission and then is put on a resold and there's a profit for it. So TNB power plants do not actually generate profit. Okay. And this is known as bundling costs. And this bundling cost is actually practiced in Sarawak. Sarawak does the bundling cost. Okay, but in Malaysia, we have actually gone into unbundling. And this has been in use very, very recently. It has only came into picture mid last decade. Okay. When you look at the IPP, they are being paid, and TNB, okay, also makes money from the GenCo. Okay, and this portion known as unregulated income. Okay, so now moving forward a bit more, now let's talk about what does it cover. You look at the generation operations, you have single buyer, grid, all of that. What does it cover? So there's two components. One is known as operational expenditure, also known as operational allowances. It covers everything from wages, repairs, bonus, rents, fees, including street lightings. The federal roads under the government is now fully the responsibility of Tenaga, and TNB actually has to cover that. And the government allows TNB to recoup that cost through putting tariff on all the other fellows except themselves, okay, and including paying taxes, okay. And the capitalist allowances, we make sure TNB consistently upgrades their transformers, cables regularly, and all kinds of needed to ensure that. And this is one of the reasons why Malaysia actually has one of the, Semenanjung actually has one of the best power system on the planet, because we ensure that TNB actually spends on the capital, and the capital does not actually go. Any excess in capital has to be refunded back to the people through the ICPT, which I'll discuss a bit more in a while. Okay. And when you look at other comparisons by America, a lot of the power utilities company, which has been privatized and sold off, their assets and equipment, some of them are actually up to 40, 50 years old. They are very unreliable. They collapse very fast. And in Tenaga, if you look at the operations allowance, there is also a special allowances just to cut trees. Not cut for TNB cables that runs along Taman and everything. So it prevents the branch actually falling onto the cable lines and bringing down the power lines. So this is one of the reasons why we actually have some of the lowest blackout rates. It is measured as SAIDI and SAIFI. Anyone interested can Google about it. It's called a SAIDI and SAIFI. So in terms of blackout rate, we're actually one of the lowest because we actually spend a lot on maintaining the grid operations properly. And TNB's amount profit from this operation is capped at about 7.3%. Okay, and this can only be approved by the minister. So if TNB makes a lot of profit, you need to take up to the minister, because it's the minister who approved it. Okay, and it's the federal minister who approved it. TNB has any extra cent he makes it from it, doesn't belong from them. Okay, now the other portion is ICPT. Okay, this is generally on the generation side. Okay, we are bulking up single buyer and generation, but you bake that through. What happens was it has two components. One is one is a fuel component, one is IPP fees. Okay, any excess from the cost of generation, say if there's an excess cost, you put a surcharge. Anything that goes down, you get a rebate. Okay, but most household residents do not get that because they are actually insulated from the fuel fluctuation. Domestics, commercial industry, large operators, they actually see a change in it, and the surcharge and rebate is changed on every 6 months. So the duration on January 1st, there will be a change, and then the other one will be on the 7th month, which will be on the 1st of July. Okay, so that's why sometimes you see TNB is increasing by 1 cent, by 2 cents, and so on. So it actually plays around with 1-2 cents only. Okay, and any excess revenue TNB made in the previous financial year or previous half year actually goes back into as rebate. So you need to put a rebate. So TNB's revenue is actually really capped. There's nothing much they can do about it. Okay. And when you look at the pass-through cost, there's actually all governed by PPA, our purchasing agreement. Like I said, all the energy and fuel is actually purchased by Tenaga. And all of this actually goes into determining the ICPT. Okay. Now, when we look at ICPT, is actually, on the generation cost, there's actually two parts to it. One is IPP fees. Okay, the other one will be fuel costs. And fuel cost is fully borne by Tenaga's fuel, TNB Fuel Service Sdn Bhd. It's actually a wholly owned subsidiary of Tenaga National. So the fuel is actually on coal from imports, fossil methane or fossil gas from Petronas, diesel, which is usually bought from the open spot market, and of course the cost of transporting fuel barges. Okay, so because all 100% of the coal in Peninsula actually comes from it comes from other countries. We are fully importing it. 66% of it is actually coming from Indonesia. So we need to bring it there. When you look at IPP fees, there's two portions of it. One is capacity payment. Capacity payment is a fixed payment. Surely you'll make profit. The wage, the remuneration, your taxes, your rent. It ensures you get at least, a maximum of 8.5% of profit return. known as internal return rate, IRR. Okay, it has been put in cap since 2011. And the other one is known as energy payment. I'm sorry, that is not wages. That was supposed to, there's a mistake there. The energy payment covers what we call as consumable items. Okay, when you conduct some operations of power plant, it actually has wear and tear, like your car, like your spark plugs and everything. So all of this has to be changed. The more you use it, the more you hire consumable. So energy payment comes as consumables. It also comes on higher operations. It comes on more standby. Depreciation rate is also there, and you also make a slight amount of additional profit from it. So there is a lot of there. Okay, so it is energy payment is measured in terms of amount of energy you supply to tenaga. Capacity payment is whether you sell or not, you still make on money. And the capacity payment is actually a fixed profit. Some people call it a fixed deposit within the industry, because as long as you have a power plant, the capacity payment is paid to you even if you don't run, and you actually get return of your capital. You can pay your bondholders, your banks, all of it you can actually pay. And minimum power purchasing agreement is 21 years for gas and 25 years for coal. All renewable plants are given 21 years. Okay. Let's grab. Okay. Now, when you short all of this, when you look at the cost of the tariff, 1/3 of it is fuel. The other 1/3 is IPP fees. Of course, you further break down, you have wages and non-wages and also profit. And then the grid is actually 1/3. So this is not really the most accurate 1/3, but it's more or less in that sense. And it changes all the time because fuel prices actually rises and go. But when you look at the overall for the past 6 years, over the past 3 years, you prorate it. The fuel actually makes about 1/3. IPP fees make 1/3 of it, and electricity grid makes actually 1/3. Any excess fund must be deposited with KWIE. It is managed by Suruhanjaya Tenaga, and with the minister permission, it is actually spent for subsidies for development, rural electrifications, and so on. Okay, and this money is not part of the national budget. It is not reported in the annual budget. It is actually a separate budget, and it's the full discretionary power of the Suruhanjaya Tenaga with the approval of the minister, the relevant minister. Okay, and when you take that cost, they will make sure they manipulate the tariff, which is why you see a certain sector have higher than the other. And it is actually done in such way that your sales amount or your revenue from that sector is near similar. So when you look at industry, although they make less 0.3% of the entire customer for TNB, but they consume about 38% of TNB's electricity. And so they pay up to, they contribute to about 37% to their revenue. Okay, you may not get it very near to accurate, but this is more how they work. They have the base tariff, and then they use it, they make backwards, and then they make sure that that particular sector contributes that portion of revenue, and then they work it more backwards and go. And when you look at household, the first 200, the first 200 is called the universal band, and the price has not been increased since 1997, but the rest of it has been on the increase. Okay, and we are expecting the next electricity tariff rise on the 1st of January 2022. Okay, and when you look at Sabah and Sarawak, like I said, they are bundling costs. They calculate their entire generation costs, their transmission, their upgrades, everything, all of it, and then they decide what is the portion to it. Which is why when you look in terms of profit, whether it's for generation transmission, Sarawak actually is way lower than Tenaga, because when you look at the Semenanjung, what happens is you have a transmission and distribution profit rate, and then you have a profit rate for IPP also. And when you factor all in that, you realize actually Sabah is actually quite. They actually don't profit too much from their do not profit as much as Semenanjung. Okay, and for Sabah actually the grid is so weak that it's actually running in loss. TNB is actually cross-subsidizing Sabah from Semenanjung. Okay, and when you look at Sarawak, they actually make a clean, decent profit, and a lot of income from the industries in Sarawak is actually given for rural electrification. Sarawak is expected to reach universal electrification by 2025. The grid operation is slightly weaker than Malaysia, but in terms of financial management and equity, they are quite okay. Now, slightly looking at IBR for TNB, because I just spoke about Sabah and I gave very good credential about Sarawak. I gave good credential. So when you look at this IBR, since it was implemented, you have to look at specifically at this portion, return on asset. Okay, and when you look at the return of asset, it's actually in a decline. Okay, so last time, before we use of IBR, It was actually a double-digit growth and return. And if you could, okay, so when you look at this return of asset, it's actually in decline because we are capping on their profit. We say that because it's a monopoly, you cannot actually profit so much and so on. So this is actually not done because of a particular incident after the financial crisis. What happened during the financial crisis was the fuel cost actually came down. Majority of the gas and coal actually came down, but the IPP model at that time was pay and take. So the IPP buys the fuel and then they sell to Tenaga at a minimum cost. Okay, so when the fuel cost dropped so bad, their profit margin went so high. Some of it up to 18 to 20% at that point of time, including at the time there was already discussed of putting of one-off extraordinary wealth tax. IPP was making a shit amount of money. It was very high, and of course people were struggling because of the financial crisis. And TNB profit was also becoming very unregulated. It was so high. And because of the huge amount of participation of privatization, of course, now they call it as liberalization. And that's where the IBR came in, the IBR ICPT, where we unbundle all of it, look at the cost individual by individual and say, Tenaga, this is the amount you can make it from here, anything more you have to refund. And then we start looking at the amount of profit. So the amount of profit made by IPP was capped at about 8.5% from 2011 onwards, and all the older IPPs have actually adopted the what we know as IPP Gen 2, which is what I talk about, the energy payment and also the capacity payment. So, and any fuel savings goes to the people, and we kept their profit, we kept that. So it has actually reduced the returns of assets and the profits for the shareholders across the board compared to any other. So of course, shareholders are not happy. But when you look at it, how about the workers? Are they benefiting? When you look at IBR, Suruhanjaya Tenaga allows you to make 1 to 2% annual increment within that 3 years period. Okay, so if TNB wants to make more profit, their only choice is to reduce wages on the workers, or they have to curtail their wage expenditure because they cannot reduce the cost on fixed expenditures like rents, taxes, and so on. So the only place they can actually expand their profit is they need to reduce something. So, profit is actually revenue minus expenditure. And the only variable they can work on is actually on the workers. And if you look at the benefits of TNB staff today compared to 30 years ago, it's actually been in steady decline. A lot of TNB workers last time in the 90s, or those who joined earlier period, they are given health benefits until the end of their lifetime, because a lot of electrical workers in the power lines, they get electrocuted, they fall, they break their back and so they're taken care for the rest of life. But any new people who joins Tenaga now, they get it until the moment they resign or they leave, or they have any sort of disability whatsoever. Of course, TNB gives you a lump sum, but that's about it, then they decouple with you. But when you look at all the older workers, they're taken care until their death, and they also take care of their spouse for that matter. So they had better taking care of benefits, because power line workers are actually very risky. A lot of them have actually fell down, broke their backs, broke their limbs, get electrocuted, and so on. So a lot of this kind of things have happened. It's quite dangerous. And the workers' remuneration has been slowly declined. There is another thing that we have noticed is what we know as a contract system. Of course, recently everyone was talking about the hospital contract workers. But last time, a lot of cleaners, gardeners, everything that works for Tenaga's premise, they were actually Tenaga staff, and they were actually paid quite well. They were Malaysians, and they were also in the unions, and they received bonus and everything. But in the process of liberalization, also known as perswastaan, once they were retired, they were actually replaced with contract workers. And these contract companies take migrant workers, and what they do is actually they overwork and underpay. And of course, because it is not really TNB's payroll, they don't really matter. They actually just pay to the contractors, and it's up to them. So when you look at it, does it really create entrepreneurship? Not really. You actually kill a few local jobs, and the contractors actually pay to suppress wages. And you're seeing this trend along the way. And the other trend you're looking at is now the decoupling of profit. In Tenaga, what is happening was like profit from one area is not being brought to the other area. Okay. So a vast majority of profit TND comes from their grid, from transmission and distribution. Okay. And that profit is later reinvested by Tenaga into other divisions. They buy renewable energy assets in UK. They invest in other new means of production. But that profit is not flowing into the people in the TNB generation or transmission and stuff. So the profit comes out from here, is invented in new modes of production, and that profit generated is not shared with the workers anymore. It is paid straight to the shareholder. So this is what we call as decoupling from the means of production as well as workers. And this is not something new. In Malaysia, this was actually first practiced by Telecom, when Telecom used its profit to buy a lot of their cellular companies globally. And it made huge amount of profit because TNB Telecom workers at that time actually recognized the need to move away from telephone lines. Okay, but what happens? Axiata decided to not to share the profit with, sorry, not Axiata. Khazanah decided the only way not to share the profit to the workers' union in a collective agreement was to split. And you got Telecom International and Telecom after that. Telecom International take away all of the international cellular operation, including local mobile operation, which is known as Celcom, and it was rebranded as Axiata. Okay, so all the profit now flows into Khazanah, into bureaucrats, into technocrats, and the workers in Telecom has been the anak tirikan. So this is the internal restructuring that we initially saw, and now TNB seems to be practicing that. And of course, it pushed down the throat by Suruhanjaya, Tenaga and Kementerian. So yes, the people are getting a more fair bundle prices. Yes, TNB profit is curtailed, but the other stakeholder of the workers, what happens to them? So that is a question that we need to think about. I will just quickly skip a few things, and thank you very much. Over to you, Mani. I'm so sorry it took quite a very long time.
Anyways, thanks for the interesting presentation.